what,
All right, Mr. Wharton is about to pop some tags with this individual section, Polynomial Division 4-4. Oh yeah, going to a thrift shop. Okay, so use direct substitution to evaluate t of a equals negative a to the fifth minus a squared plus 3. What the heck does that mean? What it means is direct substitution is I want to take negative 2, I want to plug it into my variables a, and I want to find out what to get. Okay, I want you guys to do that. Pause the video, hit play when you guys get done, and see what you get. All right, you guys should get 31. If you plugged it in your calculators, make sure you use parentheses around what number you plugged in. This negative is not changing this to a positive 2. Same thing here. Please make sure you plug it in your calculator if you did that way using parentheses. If you didn't, you got to still use parentheses when you plug numbers in. All right, we're going to use a different way to do this. Okay, instead of doing directly, we're going to kind of do synthetic. This is going to help us with the next section as well. So, synthetic substitution. What? Synthetic substitution is a method for evaluating a polynomial that uses fewer steps. You don't actually have to plug numbers in and chug them out. Okay, you don't really have to do that. So, here are your steps here. Steps 1, 2, 3, 4, 5. Step 1, write the value to be evaluated outside in the coefficients in descending order. Again, I'll go through all these specific steps. You can read the rest of them. I'll kind of talk about them. I'll hit them as we go. So let's do an example here. Okay. What I want to do is I want to evaluate this function at negative 1. Okay, at negative 1. So what I'm going to do is I'm going to take negative 1 and I'm going to place it right there. Just right there, you know, right out front. Then what I'm going to do is I am going to take these coefficients, that's step 1, write the value outside, I did, and then the coefficients in descending order inside. Okay? What I mean by that is this. X to the fifth is the highest one, right? 5, 3, 2, there's the biggest one. So the coefficient of x to the fifth is negative 1. Now you notice I don't actually have an x to the 4 there. Sorry, x to the 4. I don't actually have 1. There's not 4 there, so that means I have 0 of them. You have to account for numbers that you didn't use or you don't see. Okay? 3, negative 7, that's the coefficient. 2, I now have 3. If you notice, I don't have an x as well. All right, there's no x term, so that means that's a 0 as well. And then a negative 2 at the end, because that's our last one. That's really x to the 0 power. Okay, so I go from 5, 4, 3, 2, 1, 0. Now we got a kind of like a little funny looking box here. This is always going to be, this is what it's known for, synthetic. Okay, this is what you're using. This is kind of the diagram for that. So here's how it works. The first term, you always drop it down. Drop it like it's hot. Okay, drop it down. Then you are going to multiply. Okay, so like it says here. So write the product from the last step underneath the second coefficient, add and bring down and so on, multiply, our number bring down. That's all we're doing. So just real quick, drop it like it's hot, multiply by the number here. So negative 1 times negative 1 is positive 1. Then guess what? I'm going to add, and I get 1. 0 plus 1 is 1. I'm going to multiply. Negative 1 times 1 is being multiplied to get negative 1. I'm going to add negative 7, negative 8, negative 7, negative 1, make a negative 8. I'm going to multiply negative 1 and negative 8. I get positive 8, right? I get, add them here, I get 11, okay? Multiply, that's a negative 11. Add, that's negative 11. Multiply, that's positive 11. And then I add here, and that's 9. So what you get is t of, what do we plug in? We plugged in negative 1 there. So t of negative 1 equals 9. So when I plugged in negative 1 to the t function, I got 9. This is how your answer needs to be written. T of the negative 1 equals 9. Not just 9. T of negative 1 equals 9. Okay, let's go to this one here. You notice this one looks pretty similar to the one up top, but it's not exactly the same. Doesn't really matter, right? So we take the number that we're evaluating it at. We put it out front. I'm going to make my box now because I can. And then we take the highest power coefficients, negative 1. Well, 5 and then 2, where we skip 4 and 3. So that's a 4, that's a 3. I have 0 of them, so I still have to account for them. This 2 here becomes a negative 1, the coefficient. then I have a 1 in front of that a, and then I don't have a number over here with no variable, so that again is now a 0. I got to account for it. First one, we drop it like it's hot. Multiply by the number out front. Always multiply by the number out front. Okay, always, 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 always multiply by the number out front. It says it right here. Multiply by the number on the left. Boom, boom, boom. So that's 2. Then we add. We get 2. Then I multiply. I get -4. Then I add. I get -4. Then I multiply. I get 8. Then I add. I get 7. Then I multiply. I get -14. Sorry, -14. Then I add -13. Multiply 26. Add 26. This here is your answer. How do I write it? I got to write it this way. T, because that's the function name, of what number we plugged in was -2, equals, what did we get out? We got 26. That is how you write your answer. That is what we call synthetic substitution. So instead of having to plug it in, chug them out, you know, this probably is a little easier, but this method down here is going to help us when we get to synthetic division. Okay, polynomial long division. What? Long division? You guys thought you were done with that. And we're not in 3rd grade, 4th grade anymore. What do I care about long division? Well, long division actually works with any polynomial if I'm trying to divide them. So technically, I'm trying to divide this 3x to the 4 minus 5x to the 3rd plus 4x minus 6. I'm trying to divide this by this trinomial. And I want to see what I get. Okay? And then I'm going to take this polynomial and I'm going to divide it by that binomial. Okay? And I want to see what I get. So again, we're going to use long division. Actually, later on, I'll show you a kind of shortcut with these as well. So let's get started with this long division. If you need some room, make sure you write a little bit small. If you're a gigantic writer, then you might need some more paper to write on. Okay, so the x squared minus 3x plus 5 is going to go out front, just like when you did long division back in junior high, elementary, whatever it was. Okay, then we have our box here. Remember, this box is kind of like the opposite box of synthetic, right? It also looks like a square root with no little hook here. And then 3x to the 4 minus 5x to the 3 plus 0x squared plus 4x minus 6. Where did I get 0x squared from? Oh, guess what? It's right in here, right? There's no 0x, there's no x squared term, so I got to account for it right there. Now, let's start dividing. Some of you might ask, how do we actually do this? It's not that bad. We just got to kind of follow procedure here. How many times does x squared go into 3x to the 4? Well, it goes in 3x squared times. Because if I multiply this one and this one, I get 3x to the 4. We want to cancel stuff out. That's the only way I can do that. Now, because I multiplied 3x squared by this, I have to multiply it by those two terms as well. Remember, distributing property. So 3x squared times -3x is -9x to the 3. You notice I want to line these up with the same variables, okay, and the same exponents. I don't want to put 9x to the 3rd underneath the squared or over here. I want to make sure it follows underneath. 3x squared times 5 is 15x squared. Now I distributed everything, so now let's go here. Okay? How do I get rid of 3x to the 4 and 3x to the 4? Remember, I have to subtract them. Well, I'm subtracting, so that means I'm going to subtract everything. So 3x to the 4 minus 3x to the 4 is 0. I'm not going to write it. Negative 5x to the 3rd minus -9 becomes a positive 4x to the 3. Remember, two negatives make a positive, so really I'm adding these, right? Or actually subtracting them, right? And keeping the higher sign. And then 0 minus 15 is minus 15x squared. Plus 4x minus 6. I'm dropping these down, dropping them like it's hot. Again, haha. Now let's go again. How many times does x to the 2 go into 4x to the 3? That goes in positive 4x times. 4x times x squared is 4x to the 3. Right? 4 times 1 is 4. X times x squared is x to the 3rd. Now let's distribute with the rest of the terms. 4x times -3x is negative 12x squared. 4x times 5 is 20x. So now, let's do that. These cancel because I'm subtracting. Negative 15 minus negative 12 is negative 3x squared. 4 minus 20 is negative 16x. and then drop this last term like it's hot. So now let's go on and get one more step here. How many times does x squared go into negative 3x squared? Negative 3 times. So negative 3 times that is negative 3x squared. Negative 3 times negative 3x is positive 9x. Negative 3 times 5 is negative 15. So now let's finish that out. These get canceled because I'm subtracting. Negative 16 minus 9. Okay, negative 16 minus 9 is negative 25x. And then negative 6 minus negative 15 is actually negative 6 plus 15, right? So that's positive 9. So here's what our answer is going to look like. This is what it goes into, but this is our remainder. Remember when we long divide at the end, when we do actual numbers in middle school, junior high, we get numbers at the end. Those are our remainders. So how do I write my answer? Here's how I write it. I get 3x squared plus 4x minus 3, okay, plus, now I'm going to take this. This is my remainder. Remember when you guys did long division for the first time, my remainder went over what I'm dividing it by. So it's going to go over what I'm dividing it by. So there is your answer there. That's long division. That is polynomial long division. Hence the name long. It's pretty long. Okay, so let's do this one here, letter B. This one's going to be shorter because I only have a binomial. So m minus 2, 6m to the 4 minus 12m to the 3. You notice I don't have an m squared, so I have 0 of them. Plus m squared, plus m minus 2. So now let's divide. Okay, how many times does m go into 6m to the 4? That goes in 6m to the 3 times, because this times m is 6m to the 4. 6m to the 3 times negative 2 is negative 12m to the 3. Okay, so remember I want to make sure I line up certain things. So now let's subtract. 6 minus 6 is 0. Negative 12m to the 3 minus a negative 12m. I'm adding these, so that becomes a 0 as well. Oh, that's pretty convenient. And then let's drop it like it's hot. What's left? So I get 0m squared plus m minus 2. This 0m squared, what does that actually mean? I have 0 of them. So if I'd say how many times does m go into 0m squared, it doesn't go into it, so I don't actually need this here. Okay, whenever I drop a 0 down, you don't actually need it if it's the first term there. But if I still have it at the end, I still got to drop. So because I dropped that and dropped that, now let's figure out. How many times does m go into m? Well, that's just a 1. It goes into it 1 time. So 1 times m is m. 1 times negative 2 is negative 2. Let's subtract. I get 0. So my remainder is 0. So that means that if I were to take m minus 2 and multiply it by 6m to the 3rd plus 1, I would get this right here. Okay, it's pretty kind of crazy, right? You think about it. So my answer is 6m to the 3 plus 1. That is my final answer for letter B. All right, what I want you guys to do is go back through, try letter C. Remember, this binomial goes out front, n to the 4, 3n squared. Remember, we don't have a something over here, so that gives B as a plus 0. So try letter C yourself, and then hit play when you get done and see what you get. Okay, so when I divide this, you notice I had to write a 0 at the end here, and I just multiplied through, and then you get 0 at the end without even having to do another multiplication. Because you had 0 as a remainder here. So your answer is n to the 3rd minus 7n. That is what you have left for letter C. Here's your work right here, so if you need help, kind of look through that, but that's your work. Okay, so synthetic division is just a very simpler way of dividing polynomials. Okay, it's very, very efficient, and it's very, very quick. It's actually a lot faster. You won't have to do as much writing, so it actually benefits you in all those ways. The only difference between synthetic division and long division is synthetic division only works for binomials. Okay, it only works for binomials. It doesn't work for anything else. Okay, it doesn't work for a trinomial or whatever else. So when I'm dividing, I have to make sure this is a binomial, which that is a binomial. Same thing here. Okay, so here we go. Let's figure out what we get now. Remember, synthetic division is very similar to synthetic substitution from above. Okay, it's the same kind of method. Now, what happens is, here's my binomial x minus 2. What I want to do is, because I know that this is a factor, I also know that the number 2 is a 0. Remember, zeros are opposites of the number that's inside, right? So if this is negative 2, the opposite is a positive 2. So this is what I'm going to use, the positive 2. So I'm going to take the positive 2, I'm going to put it outside. I'm going to make my upside down box now. I'm going to now put the coefficients of these numbers. So that's a 1, that's a 5, that's a negative 7, and that's a 2. Everything goes in order. 3, 2, 1, 0. So I don't have to put a 0 in there for anything. So remember up top, I dropped it like it's hot. I had to multiply 2 and 1. I had to add, had to multiply 2 and 7. I had to add, had to multiply 2 and 7. And I get 14. And I had to add, and I get what? I get 16. I get 16. So now, I want to divide this, okay? What does that mean? That means that I want to find out what my answer is. Remember in long division you had answers of like x to the third plus 7, x to the 2, and so on. Well, I can get the same thing here without going through all the other process. Here's how I do it. These 1, 7, 7, 16 are just kind of the coefficients of your answers. Okay? Because I'm dividing, this power, the highest power, actually drops down 1 degree. Okay, it should be a 1 up here. It doesn't look like 1, but it is. Drops down 1 degree. So this 1 is actually going to be 1x squared, right? 3 minus 1 is 2x squared. This 7 is positive 7x. Okay, the 7 goes down. 2, 1. Now we have the plus 7. Because this is really x to the 0. But x to the 0 doesn't actually matter, so I don't actually need it there. So I can just kind of erase it and get rid of it. Now, where does this 16 go? Well, remember from polynomial division, long division, this would be my remainder. Okay, it's not a 0, so I have to write it. So it's a positive 16, so plus 16. And what do I need to divide it by? I need to divide it by what I'm actually dividing it by, which is x minus 2. Some of you might be like, well, this is actually a 2. I'm dividing it by 2. Yes, but with synthetic division, you're actually dividing it by this binomial. You're just not accounting for it in your work. Okay, but at the end, you need to bring it back. So this is your answer for part D. Okay, let's go to part E here. All right, x plus 3. I know it's a factor. What does that mean? A factor means this x plus 3 goes into this polynomial evenly. Okay, meaning we're not going to have any remainder. All right, so let's figure out what I need to do. X plus 3, remember I got to find the 0 of it, so that's a negative 3. Make my kind of upside down box. Coefficients are 2, 1, negative 8, and 21. Right? 3, 2, 1, 0. All right, go in order. Drop like it's hot. Multiply. Add. Multiply. Add. Multiply. Add. Because it's a factor, this is a 0, and it should be a 0 if it's a factor. Okay? So now let's rewrite this here. Remember, I'm rewriting it, so that's 2x squared. I'm dropping power down. This is a 3, I'm dropping it down. Negative 5x plus 7. Okay, 2x squared minus 5x plus 7. Now, the question then says, if so, well, it is going to be a factor. Okay, I know it says determine, but it's probably going to be a factor. So if so, factor it completely. So what I want to do is I want to take this and I want to factor it. So now let's factor this using my x. That's a 14 and that's a negative 5. Okay, so you tried to factor this using the x here, and actually if you think about it, you can never find two magic numbers that will multiply to 14 and add to negative 5. So because it says factor completely, I still have to do that. So what times what gives me our original polynomial function? It's x plus 3, okay, times the 2x squared minus 5x plus 7. All right. This cannot be broken down any further. So these two polynomials, the binomial and trinomial, multiplied together will give me our actual original polynomial after we divided it. Okay? So this is your answer for part E. Let's move on. All right. So it says, suppose you know that x equals -2 is a 0. Well, we already know what the 0 is. If we didn't know what the 0 was and it said x plus 2 is a factor, okay, that means that, again, the 0 would be -2. Remember, we need the opposite of the binomial. So if it's +2 here, we need a -2. Again, make sure for future reference you know that. It is the 0 of this function. Find the other zeros. Okay, find the other zeros. So let's get into it. So I got to take -2 outside my box. Then I take the coefficients of my values there. So that's a 1, 2, -9, and a -18. You notice I didn't skip any. 3, 2, 1, 0, going in consecutive order from greatest to least. So let's drop it like it's hot here. Multiply, add 0, multiply, add, okay, multiply, add. All right, so this remainder of 0 means it is a 0. That's what it tells me. Okay, it should be. That's what I should get. So what happens is I need to rewrite this as my x squared and all that stuff. So remember, we drop the power down, so it's x squared. This is really a 0x minus 9. This 0, we don't have to write it over here because it is, you know, a 0. It's no remainder. So let's rewrite this. I get x squared minus 9. Okay. I want to find the other zeros, so this has to equal 0. Okay. I want to solve this. How do I do that? Make an x. -9, 0 is on the bottom. Okay. Remember, b is 0. -3, 3. Take these two numbers and flip, coming out. So it's +3 and a -3 divided by my a, which is 1. So my other zeros are 3 and -3. Along with -2 from before up here. So our zeros for this equation, or this function here, are 3, -3, and -2. That wasn't so hard. Okay, that wasn't so bad. Let's go on to the application problem. Okay, suppose the profit P in millions of dollars for a new Algebros t-shirt manufacturer can be modeled by that P equals all that stuff there, where X is the number of bro shirts made in millions. Currently, the company produces 4 million shirts and makes a profit of $4 million. Can the company make a lesser number of bro shirts and still make the same profit? So according to this particular problem here, we want to find out if there's other numbers that I can technically plug in and get the same number out. Okay, so let's figure out how to do this. So first, let's write down the actual P function here. So P is equal to -x to the 3 plus 4x squared plus x. Okay, so 3, 2, 1, and then there we go there. Now, what does it say? It says profit is the letter P there. So profit is in millions of dollars. And how many millions of dollars did they make in profit? $4 million. So this P is actually going to be 4. I'm going to kind of plug that in there. Okay, and I still got all this stuff over here. Then this kind of looks similar to a polynomial function, but this doesn't equal 0, so I need to bring it over, and now it will equal 0. 0 equals -x to the 3 plus 4x squared plus x minus 4. Remember, I got to subtract that to bring that over. I have a function here, and I got to find out kind of what I'm doing. Well, it says that I'm producing 4 million shirts. Okay, producing 4 million shirts. That means that this 4 million shirts makes the $4 million. Therefore, I know that this number 4 is going to be a 0, as you want to call it, of my function. So now I'm going to take the coefficients of my actual function here and plug it in. -1, 4, 1, and -4. Right, it goes in order, 3, 2, 1, 0. Now I got to drop, solve it, synthetic division, right? That's a -4, multiply 0. Let's solve it again there. Let's multiply, that's a 0. Let's add, that's a 1. And let's multiply, that's a 4. And let's add, that's a 0. This is what I should get. If you don't get that, then it's not a 0, okay? But this one it is. So I get -1x squared, remember, drop a power down from the original, plus 0x plus 1. Well, that's technically -1x squared plus 1 equals 0. Okay, so it says, can the company make a lesser number? So because I now have this here, I want to solve this. So find out what x's can be. So let's make our x. Let's factor. A times c is -1, b is 0, so -1 and +1. I'm solving it, so I'm flipping these numbers. So +1 and -1 divided by a, which is -1, right? A is -1 right there. So 1 divided by -1 is -1. -1 divided by -1 is +1. So according to my answers, it says that if I make -1 million t-shirts, I'll make $4 million. Well, that's not real life, right? You can't make negative t-shirts, so we know that that cannot be my answer. So if I plug in the 1 here, okay, that will be my other answer. So can a company make a lesser number of bro shirts and make the same profit? Yes, they can make 1 million shirts. That's what that 1 stands for. Remember, the 1 stands for millions of shirts. Millions of shirts. So they can make 1 million shirts. I can't spell. This should be a T and S. There you go. 1 million shirts. Boom. Application problem. Done. All right, that wraps up this particular section, 4.4. It was synthetic division, synthetic substitution, with some long division in there. But there you go. If you need any help, ask questions. If not, you should be good to go. Remember, take notes, do work, be successful.